Okay, what we're going to cover today is the last of our statistical calculations, which is what's called the standard deviation. Now, just to show you the relevance of standard deviation, if you were to take each of these two data sets, I have period 1 and period 3, and these are their test scores, okay? And you want to compute the mean for each one. And if you do that, you'll find that the mean for each period is 85, okay? They have 10 tests taken each, and they both have an average of 85. But when you take a look at it, there's something different about them. And if you notice, period 1 has a range of 10, while period 3 has a range of 40. Now, that's very simple to look at, but what you'll see is that what we've got is quite a wide range, for lack of a better term, but a diversity in the spread of the data. So what statisticians, at the end of the day, it's a long day, have come up with is another method of measure, which is called the standard deviation. And what the standard deviation is, and luckily, while I have these formulas here, you don't need to know the formulas, okay, is the measure, and I'll write this down in a second, of how far apart the individual scores are from the mean. So what we're trying to do is to figure out the dispersion of the data, okay? So just give me one quick second. I'll write down that definition up on the board, and then we'll go through some examples. So, as we've just said, the standard deviation is the measure of how far apart the individual scores are from the mean. And if you look at the formula, and the standard deviation, and I'll go through this in a second, because there's two different situations, okay? If you look at the formula here, this is the Greek letter that's is the symbol for standard deviation, okay? And that's the lowercase sigma, okay? And the way this formula works, so this is the lowercase sigma here. That's just the standard deviation. And what we're first talking about is entire population. And again, as I said, the calculator does this for you. You just need to know what it shows up on the calculator, okay? This is uppercase sigma, which means the sum. This means take every score, in parentheses it says take every score minus the mean, square that, divide it by n, which is the number of scores, and then take the square root of that, okay? Now, if you're doing the entire population, you would use this formula. If you're doing a sample, okay, then it's basically the same thing but n minus 1 to try to adjust for the sample size, okay? Again, you don't need to know these formulas. The calculator will do it. But I do want to show you, because you could be asked on the Common Core regions, to fill in these tables, and I want you to understand and feel comfortable with what they are saying. Okay? So, how would you do this? The first thing you would do is you would determine the mean of the data set. Then you want to determine the amount each value in the data set deviates from the mean, which is called the deviation from the mean. How clever. Okay? You square each value that you just computed. That's called the squared deviations. You sum them up. You divide that by n, if the entire population, or n minus 1, and then you take the square root of that. So let's just see how this works here in the example we just did. Okay. So what we're going to do is we're going to compute the standard deviation by hand. So I'm going to list out, here are all our scores. Okay, our mean was 85. That's going to go all the way down. So I'm just going to do the subtraction. And then square each number. Okay, when I sum all of this up, I get 110. Since it's the entire population, I divide it by 10 and get 11. And then the square root of 11, 3.32. And we can verify this on the calculator. Now I'm going to do the same thing for the next period. So I list out all their scores. I do my computations. Sorry, there's no way to avoid the tediousness of this. Okay, I sum all of this up. I get 2,500. I divide that by 10, get 250, and I take the square root and get 15.81. So how does the standard deviation compare to each of these? And so the period with the higher range of test scores has the higher standard deviation. Okay? So what we really just want you to get out of this lesson is the concept that a standard deviation is an additional tool used by statisticians, okay, to show or to help determine the disbursement of the data. And the larger the standard deviation, and the more widely dispersed the data is. And what you'll see when you go on in math, other uses of this standard deviation.